Hello friends, today we will see one numerical on steady flow energy equation. Now the problem statement is in front of you. So let us see the problem statement. Steam enters a turbine with a velocity of 40 meter per second and specific enthalpy of 2500 kilojoule per kg and leaves with a velocity of 90 meter per second and specific enthalpy of 2030 kilojoule per kg. Heat losses from the turbine to the surrounding are 240 kilojoule per minute and the steam flow rate is 5040 kg per hour. Neglect the change in potential energy. Find the power developed by the turbine. So this is the problem based on steady flow energy equation. Now let us first try to understand the function of a steam turbine. So steam turbine is a device which converts heat energy of a steam into the kinetic energy and then to rotational energy. So this is the schematic representation of a steam turbine. These are the inlet conditions we have shown here. So this is the outlet and this is the rotational energy we get through the rotation of this shaft. So here we have to calculate the power developed by the turbine with the help of steady flow energy equation. So in such types of numericals or examples, first thing is that you should be visualize the problem carefully and read the problem statement at least for 2 times and try to understand the concept given in the problem. So let us make a list of a given information in the problem. All the inlet conditions are mentioned in the problem. Inlet conditions, this is the inlet and this is the outlet. Inlet conditions H1, that is enthalpy at inlet 2500 kilojoule per kg, velocity V1 40 meter per second, heat losses through the steam turbine Q is equal to minus 240 kilojoule per minute. We have converted in a kilowatt, so just divide by 60, we will get minus 4 kilowatt Q. So let us try to visualize the steady flow energy equation. So these are the outlet conditions, enthalpy at point 2 2030 kilojoule per kg, velocity at point 2 90 meter per second, and we have to calculate power developed by the steam turbine. So we know that steady flow energy equation is Q minus W is equal to M in mass flow rate in bracket delta H plus delta KE plus delta PE. So in the problem it is mentioned that we have to neglect the potential energy. So this term is going to become 0. So let us say this is our equation number 1. Let us calculate each term of the steady flow energy equation separately. So delta H, that is change in enthalpy, H2 minus H1. So we know the value of H2, we know the value of H1. So delta H comes minus 470 kilojoule per kg. Similarly, change in kinetic energy, V2 square minus V1 square divided by 2. So that comes 3.25 kilojoule per kg. Put all the values of each term in equation 1. So Q minus 4 minus W, that W we want to calculate this term, is equal to 1.4, that is mass flow rate, multiplied by, that is this is the change in enthalpy plus change in kinetic energy plus 0 is change in potential energy. It is neglected term. So by calculation, after the successful calculation, we get the value, that is power developed by the turbine is 649.45 kilowatt. So trick to solve such types of problem is you have to read the problem for at least 2 times and try to visualize the things and make a list of a given data perfectly and utilize properly the steady flow energy equation smartly. Okay, thank you.